So here, my three executable files are in the AERSCREEN folder. Right now it's inside this downloads folder, so I'm going to navigate to that. Type cd AERSCREEN. Oh, by the way, one tip is that if you like to not type the entire name of the file, if the folder is there, you just press tab. If the name of you just continue, like say for example AERSCREEN, you just type AER and then you press tab. If the folder or the file is there, then it will autocomplete. The trick is the tab. But if you press tab, it doesn't show, that means it's not there. So you notice here, I type CD and then I just type the three first letters of the word, and I press tab, it auto-completes. If the file or folder is there. If it's not there, it will not auto-complete, something is wrong. Okay. So I go inside there and then AERSCREEN, I check the files inside this folder, and I see the tree file. Okay, maybe I'll just explain a bit about this. By the way, this is the normal way we navigate computers last time in 1990s. The first time when I have my own computer, we used DOS. I'm not sure whether you are in that, you ever used that type of computer before, but I use this. So that's why I'm okay with this. But now, this is still there. It's just that it's covered by all the GUIs that you're used to. But it's the main structure or the main the underlying structure of Windows is this, at its most basic level, and this is what we'll be using. Okay, so anyway, inside this directory, if you press if you run the command dir, you get a list of file. So this is the date and time of the file, and then dir means the directory. So there's two actually in this folder. You see this dot, right? This means that there is a hidden folder inside this folder. And the name of that hidden folder is dot for one, and the other one is dot. But you don't need to worry yourself about this. It's just there. It's set default by Windows. And you won't see it inside Windows, inside the GUI. For example, here, I don't see the dot. It's just hidden. You can ignore it. And then the next file is this, airmod.exe. This is the size of the file. This is in bytes. So that means this is 2.8 megabyte. And then the next file is AERSCREEN.exe, 1.7 megabyte, and micmat.exe, about half a megabyte. And at the bottom, it summarizes the number of files. There's 3 files with a total of 5 megabytes. There's 2 directories, and then there's this many bytes free. But this is just for you to just understand a bit about what it shows when it lists out. Okay, so how do we proceed? So we're done with navigating to the path, and then we type AERSCREEN.exe in here. So let's type what happened? Okay, AERSCREEN, not airmod, AERSCREEN. Then you press enter. Then this will show up. So you just need to follow the instruction. What makes this easy? Because you just have to follow the instructions given. So it says at the top, this is the version 14147. It says AERSCREEN.inp does not exist because we'll be adding the file manually. We'll be adding the information manually. There's another way for you to interface with this application is by giving an input file. That input file is this, AERSCREEN.inp. But you don't have this. Remember, when you look inside the folder, is there a AERSCREEN.inp here? None. So that's why you cannot find. You will just proceed with the manual way of input the data. So it says, since this input file does not exist, user must enter data. So you just enter data, initial information. Then you go to this slide. Remember, I give this information. It says title, simple 1 point. So you just type. Okay, I'll just do this in front of you. Simple 1 point. Spelling all doesn't really matter. It's just to give it a name for this project. Press enter. And then English or metric unit, we'll use metric, so capital M. Is it what type of source is it? Is it a point, volume, area, circle, or is it a flare? So 5 types of sources. Just now I mentioned 3, right? So there's actually 5 types. So it's a point source, so we capital P. That's why here capital P. And what is the emission rate? I put here 1 grams per second. The stack height, 10 meters, type 10. The stack diameter, 0.5. And then the, okay, it says here, enter stack temperature in Kelvin. Enter 0 for ambient temperature. If we don't know what's the stack temperature, we just assume it's ambient temperature. Or a negative number for temperature difference between stack temperature and ambient temperature. But we just put in, okay, let's say it's the temperature of the stack is 313 Kelvin. So just type in there, 313. Don't write the units, just write the number. And then how do you want to input the emission rate? Is it the emission velocity? Is it exit velocity in meter per second? Is it exit velocity in feet per second? Or maybe the flow rate in ACFM, actual cubic feet per minute. So we use the SI method. We use the SI unit. So we use the exit velocity here for the M/S unit. So option number 1. Press enter. What is the exit velocity in meter per second? 5. Okay, is the surrounding area rural or urban? So I just choose urban. And then what is the population of the urban area? Just an estimate, about 500,000. What is the minimum distance to ambient air? So the default is 1, so we just use the default. And then whether we want to consider any chemistry, atmospheric chemistry inside this model for the run, we just go for the simplest one. There's no chemistry, so we use option number 1. No chemistry or pollutant is not nitrogen dioxide. Just choose option 1, press enter. Do we include building downwash? No. Include terrain height? We don't have it right now. No. Enter maximum distance to probe. This one, let me check. 5,000 meters. Now this one, it's let me get back on to you about what this means. But I think it's something about the boundary of the model, the furthest distance away from the source at 5,000 meters. So that's about 5 kilometers. So 5 kilometers is quite far to model too. It's not accurate anymore after that. So we just put here 5,000, the default. Okay, are you going to include 10 discrete receptors? Now 10 discrete receptors means right now it just auto-generate the receptors for you. You know what does receptor mean? Remember the grid that I mentioned? The grid and then the stack is in the middle, and then you will calculate for each grid point. So each grid point is a receptor. So that's auto-generated by the model. But let's say if you want a special 10 separate receptors, so you can put it here, like a specific position. If you don't put it this one, then it will auto-generate the receptor. If you put in, then you can specify the exact point that you want to calculate. For example, sensitive areas, let's say residential areas or schools, you know the position of this point, and you want the model to specifically run for this discrete or this separate receptor. So you can specify up to 10 receptors. Later, right now, no. So this is a simple run, right? So we just put none, no for now. Okay, use flagpole receptors means if it's above the ground. Right now we are modeling the concentration at the surface, about 1 meters from the surface, the height of our mouth, or where we breathe. So, but then if you want it to be a higher elevation, then you can put in flagpole receptors. So of course here no. Most of the time you'll be using no anyway. You don't really care about what is the concentration up there. Enter source elevation. So source elevation is okay. You have a stack and you assume the stack is at mean sea level equals to 0. But what if the stack is elevated slightly above the mean sea level at about 5 meters, 10 meters? And you could, if it is, then you could type that the height in meters, or if it's not, then you just type 0. So here we just assume it's at the mean surface level equals to 0. And what else? Let's see. Okay, enter minimum maximum temperature. Okay, now this is the meteorology part. Notice it says make mat meteorology. So make mat would use this limited information that you put in to give a maximum and minimum situation, the meteorological situation of the area. So here, you notice that we don't need meteorology data here, because it's meant to be for screening. If it's for refine, then you need detailed meteorology data. For this one, you don't have to have details, but you need to have a rough idea of what the meteorology is like at the area. So here is where we put in what is the estimated minimum temperature of the area and maximum temperature at that area. So in Malaysia, it's quite standard, right? The temperature is going to be the same. So I just put here minimum temperature 300. It's about 27 degrees Celsius. And 307, about plus 34, right? 34 degrees. So 27 maybe at night, 34 during the day. Just a rough estimate. So minimum temperature 300 Kelvin. Maximum temperature 307. Enter minimum wind speed. So in Malaysia, the wind speed is usually 0.5 or below, or the mean is about 1 meter per second. Maximum is about 5 or 6 meter per second, excluding gusts or severe storms. So I put here the minimum wind speed is 0.5, and that's the common wind speed value. So I type in 0.5. Enter the anemometer height. Now this one default 10 meters because the standard height of anemometer placement. Anemometer is the sensor to measure wind speed. The standard height to place anemometer is 10 meters. So if you notice any met station or even air quality station, if they have an anemometer, it will place about 10 meters from the ground. It's a standard height to place anemometers. So just type in 10 meters here. That's the default. And then, okay, the next one, surface characteristics. No, we're not going to, oh yeah, we are. Surface characteristic option is a single user specified value. So here, 1 is single user specified value. Option number 2 is AirMat seasonal value. And 3 is external file. We're going to use the simplest one, number 1. We're going to specify the manually the surface characteristic. So albedo, 0.2. Bone ratio, 0.5. Surface roughness, 0.5. So 0.2, 0.5, and then 0.5. And then you have to name the output file. So the name of the output file I chose here is simple one point.out. And then you have to type the .out. Then press enter. So this is the summary of the data that you input into the software. The summary of it. It's not the run of the model yet. It's a summary. So you can double confirm the values that you put in. And then at the bottom here, you have a few options. It says here, AERSCREEN run is ready to begin. Choose option to proceed. Whether you want to change anything, maybe change the source data, change building data, change terrain data, no. If you don't want to change anything, after reviewing this, everything is correct, then you just press enter. Then it runs. This is the model running. Yeah, done. So you want to look out for AERSCREEN finished successfully with no errors or warnings. Check log file for details. Because it's a simple case study, so it runs quite quickly. Now, if you use terrain data, then it might take about an hour to run. But now you don't use terrain data and so on. Depending on your computer, of course. Just now there's only 3 executable files, right? These are all the auto-generated output files. Okay, this is the executable. And then these are one output.fil. Most of it you don't need to use. Okay, notice just now this .inp file. It says it's not found. But then we input manually the values, so it auto-generate the input file for us. This is the AERSCREEN.input. The simple one-point input. Okay, INP stands for input. The OUT stands for output. Output of the model. PFL and all that, you don't have to concern yourself. This is the temperature, the meteorological profile, the surface profile, and so on. You don't have to. You can open this if you want, but then you don't have to. And then the result is somewhere. I think should be simple one-point.out here. I think. So go back to this. So after you finish, okay, we done this. Check to confirm your input. That's that. Then this is the result. Then we open. We use Excel to visualize the data. So open Excel. Okay, locate and open the file simple one point.out. Where is that? File. Open. It's in downloads. AERSCREEN. You choose. Okay, you don't see any file here because none of it is a .xls file. It's not an Excel file, so you just choose all files. See, file type. You just choose all file. Then you see all this file, and then you find the simple one point.out. Then you open it. Okay, this will pop up. Locate. Okay, this is done. Import from row 108. Use the space delimiters. Start import at row 108. Here, the default is start import at row 1. So choose 108. And the delimited, you have to use space. So, now you click on next first. Okay, see the delimiters. You know what delimiters mean? Delimiters means how is the data separated? For example, you get the other one. I think in my room, should be my room. So the delimiters means how is the data separated. If it's if there's a few types. There's this tab, one row and another row separated by a tab. There's the semicolon, means that it's separated by a semicolon. If a comma separated by a comma, for example, maybe 10, maybe it's space and then the next data is 11, space 12, space 13. So this is space delimited. But if it's 10, then semicolon 11, semicolon 12, semicolon means semicolon delimited. If it's comma means 10, comma 11, comma 12, comma. So there's a few types. So what we want to choose is space. So the top one is tab, semicolon, comma, space, other. So choose space instead of tab. So notice the preview. Okay, it's space delimited. Then click on, let me check first what it says. Edit the file to only include distance and concentration. All right. So next, and then finish. Yeah, so that's the data. Let me check concentration. Okay. So, yeah? Yes. Uncheck it. All right. Now, if you want to see the data without using Excel, you can use Notepad. So if you double click on this simple one.point.out, then it says Windows can open the file, right? So you just open it with Notepad. How do I open it? Open. Select a program or from a list of installed programs. Choose Notepad to open it. And that's the result as well. But just you might not be able to plot straight away because this is in Notepad. But if you open it in Excel, then you can plot the concentration. So notice this line here. This is the result. AERSCREEN automated distance. Okay, distance, maximum 1 hour concentration. And then this is the second, it's still distance. That means 1 until 2,500. And then continues up here until 5,000. Remember the distance to probe, the maximum distance up to 5,000. And then the concentration is this. So if you go back to Excel, see this is 1 until 2,500. So if you want to plot this, you just choose these two rows, these two column. Which is again. And then you plot. Insert line. No, scatter, right? Should be scatter plot. Okay. Here it is. Move chart to new sheet. Okay. Okay. So here it shows the concentration with distance from the stack 0, because you cannot model the concentration at the stack point. It has to go a certain distance before you get a concentration value. So there's a bit of instability in the modeling results. So it's maximum there and then decrease and increase. I feel that this is not really correct. It's uncertainty there. It should be somewhere in the middle. And then as it goes away from the source, then the concentration decreases by this value. So at 1,000, at 1 kilometer away from the source, directly downwind, it's at about 20, 30 micrograms per meter cube. But further away, it balances out at around maybe 10 micrograms per meter cube. Okay, so can you do that now? Try it.